intensive care. Pump was powered on, setup not cleared. The user attempted to commence the infusion at 0.6 units per kilograms per hour, which was 10 times the intended rate. And obviously, you can draw your own conclusions of what could have happened if that was actually a mils per hour infusion. Again, insulin. This example gives you a feel of sometimes you have this data, you don't really comprehend what's coming out, and that's where the narrative, the kind of point prevalence observational studies would really help, which is the next stage for us. Insulin was selected, commenced at 11:24 at a rate of 6 units per hour. 4 minutes later, the user attempted to increase that to 200 units per hour. The hard limit for this was 20, so then the user reprogrammed the rate at 6 and continued the infusion. There's no real explanation to that. This is where the retrospective analysis has its flaws. Something like this, you needed to get an idea of what actually happened. You perhaps needed to be there at the time. The last example is around magnesium. The user attempted to commence this entering a volume of 900 at 125. The hard limit was 20. The user exited guardrails and commenced the infusion at 125. So logic suggests they were in the wrong drug profile. Again, that's one of the flaws of dose-error reduction software. But again, not being there at that time, we really don't know what happened. And again, it's bypassing that dose creates its own problems. So what we need to rationalise this, we need to talk about how this was affected. We need to look at return on investment. We'd invested in this, and we had to go back and present some data back to the clinicians, back to the finance director. So the simplest way to rationalise this, I kind of looked around and think, how could I simplify this to present to execs, and you only get a certain amount of time? In stepped Donald Rumsfeld. I'm not sure if everybody knows, but he was the Defence Secretary in 77-75 and 2001 to 2006. And in the midst of the weapons of mass destruction, he came out with some pearls of wisdom that kind of bemused the audience, but risk managers everywhere just jotted this down and took it from there. So I'm going to have to read this verbatim. And what he said is there are known knowns, and there are things that we know that we know. It's pretty obvious. There are known unknowns. That is to say, there are things that we now know we don't know. But there are also unknown unknowns, and these are things that we do not know we don't know. So it's kind of a little bit here and there, but when you contextualize that into the risks of the guardrails infusions, the known knowns are the completed guardrail infusions, the reprogrammed guardrail infusions. These are the things that we know about. And we can carry on all day. They're the safe infusions. The known unknowns are the infusions that are started with guardrails, but then the user decides, actually, I'm going to exit that, and then they cancel them. So we do not know what happens after that. It's really difficult to learn from any examples because the mils per hour will not tell us anything. And the known unknowns is every infusion that is used per mils per hour. So that's every bypassed infusion. They're unmitigated risk, and they're outside of the control and safety measures that we've tried to introduce. And just for example, in a 6-month period in 2016, there were 300,000 of those. And if we use the statistics in Sutherland et al., that's a potential of 30,000 errors. Just for food for thought there. Again, this always brings some contention, and I'm happy to discuss this after. But infusion pumps are expensive, and you have to show a return on investment. But again, there isn't enough universal data that will show what the statistics can count, and what the cost of an adverse infusion is to a patient. So, again, Adam kindly passed me on Elliott et al. Study, and just to kind of assume, there's a leap of faith that you have to assume that figure that we talked about, average known infusions, they're the ones that have intercepted. About 1,800 of those have been intercepted. So if we apply that and assume not every one of those will have created extreme harm, but then not all of them would have created moderate harm. So to average that out, if we assume that 4 additional bed days were taken for each of those, at a cost of $330 per day, that's an average bed day on top of the care. That comes out at an additional cost per incident of £1,320. If you multiply that by the known infusion, reprogrammed infusion, that is a cost avoidance in 6 months of 2.37 million. So it pays for